All right, hey guys, hope you're doing great. We are on page 190, 191 in our workbooks. You are gonna love today's special treat in store for you. Shouldn't be too bad, I don't think. So 190, 191. Here we are, example number 1. Let's see what we got. You're gonna like this. You're gonna like today, I promise.
How does a qualitative graph describe the relationship between quantities?
I don't know.
Think about this question during the lesson. An express train reaches its travel speed of 150 miles per hour shortly after leaving the station and travels at this speed for an extended period of time.
Yep, that makes sense.
What would a qualitative graph of the distance the train travels over time look like once the express train reaches its travel speed?
Right. So
what is the relationship between time and distance?
So think about that. As time increases, right, the train starts moving. As time increases, what's happening to its speed? Well, it's increasing until what? Until it hits that speed that hey, I don't need to go any faster than this. Here's the speed we're going to go, right? So as time increases, I think the speed of the train will be increasing. I think. Who's to
we
say?
Can draw a qualitative graph. It's
Qualitative
a little different
graphs.
from the graphs you've drawn before. A qualitative graph represents the relationship between quantities without numbers.
I just said that. No numbers.
You begin by identifying the input variable, which is time, and the output variable, which is distance.
Yep.
We also need to identify the intervals. An interval is the period of time between 2 points of time or events. The first interval on the graph begins with the train standing still and ends when it reaches travel speed.
Mm-hmm.
The second starts when the train reaches its travel speed. In which interval will the graph be steeper?
Select your answer.
Right. First interval, it starts moving. Second interval, it reaches its travel speed. What are you guys going to think? Which one?
Choose the wrong one.
Choose the wrong one? Okay. Oh! No, we ain't got time for that. We got to get going.
Determine the relationship between the two variables during each interval.
Yep.
At the beginning of the first interval, the time and distance are both 0.
Yep.
The express train starts moving at a speed less than the travel speed. The distance increases as the time increases. The second interval starts when the train reaches its travel speed of 150 miles per hour shortly after leaving the station. The distance continues to increase as the time increases. Since the train is traveling faster in the second interval, the graph is steeper in this interval.
So guys, that's one way we can see, hey, which interval is increasing or decreasing at a greater rate, right, based off of the steepness of the line, okay? So steeper the line, again, remember, it can go downhill too. We can have downhill lines that have different steepnesses, okay? Steeper the line, the greater the rate of change, right? We did that in what, 3-3?
As time increases, the distance the train has traveled increases. The function is increasing in this interval. Once the express train reaches its travel speed, a qualitative graph of the distance the train travels over time is a straight line.
Yep.
Now you know how a qualitative graph can describe the relationship between quantities.
Yeah, we do. So guys, qualitative graphs, just a graph without numbers. We kind of have to interpret what's going on here. Okay, so again, time, speed. It looks like our speed starts up here, and what's happening to our speed over time?
It's going down.
It's going downhill. So I just see one interval, right? I see one interval. Looks like it is going downhill. That we would say that line has negative slope. Okay. So here we go. As time blank, the speed of the train blank. The function is blank. I have no idea. As time, what's time doing in our graph? Well, it's increasing, right? So as time increases, the speed of the train does what? So as we move this way, right, my speed starts here, and then eventually it gets all the way down here. So my speed is doing decreasing. Okay? There's just one interval, so we can describe this function. It is a function. It passes the vertical line test. We could say this function is decreasing. Okay? There we go. There's example 1. Guys, that's what today's all about. We're going to have these things we call qualitative graphs, and we're just going to have to explain the different intervals and kind of what we see and what they mean. Let's see what they do here. Maybe they're going to give us something harder. I don't know.
The graph shows the behavior of a ball that a soccer player kicks to a teammate.
Yeah.
Describe
Soccer
how
ball.
the height of the ball and time are related in each interval.
Okay. We're going to see two intervals, right? They've got them listed here. First interval, height of the ball going up. At some point in time, what's going to happen to the ball, guys? It's going to start to come back down. That's the second interval, okay? Here you go. So this function does both, right? Our last function, we just were decreasing on our triad. Here, we can't really see both. Our two intervals, right? The first one increasing, the second one decreasing. All right, again, we can kind of visualize. I'm sure we've all kicked a ball of some sort. All right, anyway, interval 1 increasing, interval 2 is decreasing. Pretty straightforward. How many intervals do we see here? 4.
4.
4.
4.
Look, they've even numbered them very nicely for us, okay? Our graph here shows the behavior of Skyla, who is skateboarding at a park. In which interval is the function increasing, decreasing, or constant? So we just have to determine, hey, is the function increasing? Is the function decreasing? Is it constant? Okay, all right. So clearly, what are we doing in function? So here's interval 1, guys, right here, right? So this part here, interval 1, going down, right? So decreasing. Let me switch colors here. Interval 2, right? So this is this part. Interval 2, there's no change, right? We're not going down, we're not going up. No change means constant. So we're constant in interval 2. Interval 3, this one here. So now our line's coming back uphill. That's right, you guessed it. We're increasing there. And interval 4, you know, it's kind of hard to see how they've drawn interval 4. Mr. Noel and I can debate this and see what he wants to go with. If we're just talking about just the very instant right there, right, where interval 4 is just that very top part, then I would say, hey, that's no change at all, right? Because think about it, at some point in time, you're going to stop going up. But have you gone back down yet? No, right? So at that very instant, you're constant. Now, if they want interval 4 to be this whole thing here, well, then, of course, that would be decreasing, okay? So open for interpretation.
If we
there.
look at the book of the kids, not to delay your nice lesson here, the interval 4 is labeled a little bit farther to the right than the top of.
Oh, okay. So if it's over here more,
Yeah.
then I would say definitely decreasing.
Definitely decreasing.
Absolutely. Okay. There you go. Example 3. You guys ready for it? Maybe it's going to get really tough here. Okay, you guys think it's going to?
Lots of.
In which intervals is the function increasing, decreasing, or constant?
Who knows? Okay, so again, here's another qualitative graph, guys. Time increasing, distance. Again, if you're going up, it's increasing. So 1, 2, 3, 4, 5 different intervals. Again, we can easily just look for different slopes, and there's what we got. Interval number 1, again, we're going uphill. That's like positive slope, so we're increasing. As is interval 3, right? Also going uphill. 2 and 4 look like they're doing nothing, right? Is my distance changing at all in this interval? No, my distance staying the same, right? In both 2 and in 4, right? There is no change in our distance. 5, going downhill, negative slope, that's a decreasing interval, okay? So guys, qualitative graphs, intervals, increasing, decreasing, whatnot. This one says write a scenario that the graph could represent. Okay. I have to write a scenario. You guys ready for this? All right, so we are going to start at our house, okay? So I'm starting at home, and I'm walking to my friend's house, okay? So I'm in interval number 1. I leave my house and I start walking. However, my friend calls me on the walk and says, hey, can you pick up some Flamin' Hot Cheetos from the gas station before you get to the house? I say, absolutely, right? So I stop at the gas station to get some Flamin' Hot Cheetos. That's interval number 2, right? I'm not walking to my friend's house anymore. I've stopped at the store. I'm in the store. Apparently, it's super busy. I'm there forever, right? So I get the Flamin' Hot Cheetos, then I continue my walk to my friend's house. Again, notice, I'm walking pretty much at the same speed, right? That's why both of these lines have the same slope, all right? So finally, at the end of interval number 3, I get to my friend's house with the Flamin' Hot Cheetos, all right? We're there, we start to eat them. All of a sudden, I get a call, right? I got to go back home because I forgot I had to mow the grass. So,
Whoops.
Yep, whoops. Didn't think ahead, right? So I leave my friend, I give him the rest of the Cheetos. I proceed then to walk back home during interval number 5, right? Decreasing, so my distance decreasing until I get back home. There you go. There's my fictitious scenario that matches this one here. I'm sure you guys can make up one as well because you are creative individuals. So, guys, with that, we're going to get into our key concepts. That's on page 192 and everything else. So, hope you enjoyed this. I'll see you soon.